Right. It's time. It's 11 a.m. It's time for Chem 1330. And there's a couple of things that you guys need to know. One thing is that this class is undergoing like a name change. And it's not going to affect much because of the fact that none of the content really changed, but we came up with a name that's a little bit more appropriate for this class. When you registered for this, you probably registered for, or you, let me not, let me remove probably, but it's possible that you registered for this with the idea of like, oh yeah, I got to take 3 more hours of chemistry. I took 1310. Apparently 1330 is the next class to take. I will take that class. You might have also registered for it with the idea of, oh, I got to take 6 hours of chemistry or 6 hours of science. I took 1310, and Dr. Gray's teaching this. Okay, cool. I remember him. I'll take this. And I can. Done. Registered. You might have registered for it and been like, oh, chemistry for non-science majors, part two. Perfect. Um, all of these are possible situations. And let me tell you that this class is now also known as organic and biochemistry for non-science majors. The content that will be taught in this class this semester compared to last semester, compared to the semesters before, is not changing one bit. The only difference is that now it's like more appropriately named. So like I said, it doesn't really impact you guys very much. It's more of like a, I guess, like a procedural sort of consideration. Now, with that in mind, our class will meet on Mondays and Wednesdays at 11 until 12:20, and I'm going to share my screen with the web browser on. But before I do that, I'm Dr. Gray. If you were in my class last semester, awesome. I hope that you enjoy this class. I enjoy this class, and so that's a good place to start, I think. I had a teacher in high school who was my chemistry one teacher, and she said, "Listen, I only took what did she say? I took 6 hours of chemistry because that's all I needed for my degree." And then I was like, "Oh, that's awesome. This is like the perfect person to teach chemistry." The one who's like, "I didn't really want to teach it." At any rate, I'm Dr. Gray. I'll teach this class. I hope you enjoy this class. Um, and I'm going to do my best, and I hope that you will do the same. If there is anything that comes up that you're like, hey, you said you're going to do X, Y, and Z, and you haven't done that, please email me. I will do my best. Okay, so here's our Canvas page. And right now I've been tinkering around with my screen, so I've got like 5 different things going on. I don't like it. Now I need to go back to speaker view. There we go. That's what I wanted. Um, so here's our Canvas page. I view our Canvas page using a web browser as opposed to the Canvas app. So if there's something that you see that's different, or if I give you directions like, hey, go to this page or go to the landing page, um, it might display a little bit differently. For instance, this table right here that has our entire semester schedule. I know historically, whenever I've told people, oh, just go on the homepage, that table might display a little bit weird because of the width of it. But if there's something that you can't find and my directions of just go to the web page aren't clear, like I'll I'll do my best to send you a screenshot. Our first class is today. Hi. Our meeting time, 11 until 12:20. Our meeting link is right here. Now, starting next Wednesday, in order to join this class, you will have to join using a single sign-on or a secure sign-on. I can't remember exactly what it is, but you'll have to be using your authenticated Texas State account. Now, if you are unsure about how to do that, this link right here that I sent in our announcement on Canvas that I'm showing you right now and I'm adding to the chat is how you will do it. So this is how to log into the Zoom app. Open the Zoom app and then make sure that you click sign in with SSO. If you have not done this or you did not do this today, don't worry about it. Um, if you've done it in the past and you're like, I'm not sure if I'm doing it right now, then one indication is when you look at the cell in your Zoom window that shows your name in the lower left-hand corner where your name is, if your first and last name appear and they are both capitalized, that's a good indication that you have used it. If you appear as John's iPhone, for example, chances are you have not used your authenticated account. No penalty today, but starting next Wednesday, you will not be able to join. And I'm not saying that it's like you're not a, well, yeah, I am saying you're not allowed, but I'm not trying to say it in a petty way, like you're not. Instead, this is just what you have to do so that I can keep better records of attendance. This shows you everything that you need to do. For example, under company domain, enter txstate. That will take you to txstate.zoom.us, and that's how you'll log in with your net ID and your password. You'll click login, and it'll open Zoom. I believe that the same thing works in the mobile app. I'm not exactly sure what you're prompted with or anything, but make sure that you do that. So if next Wednesday you have issues logging in, that will be the barrier. And yeah, there we go. Okay. So other events, spring break, March 15th to March 22nd. Woo! No class meetings that week. Our last class will be on Monday, May 4th, 2026. We'll have a grand total of 29 meetings. Semester is basically over. We have exams. Our first exam is going to be February 18th. Then we'll have one on April 1st and April 29th. So 3 in-class exams. Our exams are all going to be administered during class on Zoom. In the event that you need some sort of accommodation for taking your exam, whether that is, well, I need extended time, and so I want to take them in the testing center, and the testing center only allows me to take them at 1 p.m., just let me know. I will coordinate with you and the testing center to make sure that you have access to your exam at the designated time. Um, and I apologize in advance. That's something that I have a bad habit of forgetting to follow up on. Like I'll send the first email, yeah, let's get that going. But then I can improve on the follow through on that. So just pester me and we'll get that all set up. I know that with the testing center, if you have accommodations, you can get all of your exams set up like right now. I have no intention of changing any of the exam dates or times or anything like that, so we can get that going right now. Your final exam will be proctored or administered on Monday, May 11th, 2026, from 8 a.m. until 10:30 a.m. The final exam schedule you can access through this link right here. Whenever you click that link, I'm going to go right there. You can look at all of your classes' final exam schedule just by sorting by class meeting days or meeting times. I'm going to sort this. I'm going to click class meeting day. Didn't really change, but now I see Monday, Wednesday, 11 a.m. to 12:20. Monday, May 11th, 8 a.m. until 10:30 a.m. That's when my final exam for this class is going to be. So there you go. Now, this below that link is basically the schedule for the semester. The first column is meeting number 1, or meeting number, sorry. We've got 1 of 29. What day? Wednesday. The date, January 21st, 2026. Graded activity for the day is discussion. I'll get into that in just a moment. Material for the day, syllabus, and then review of general chemistry. We've got it as a PowerPoint as well as a PDF, so you can access either one of those files right there. And then recording for the day. After class, I'm going to convert this recording, which it is recording, which I will over the course of the semester have like a minor panic attack, and I'll be like, am I recording? And then I'll look back, sure enough, I am. And I will post this to my YouTube channel and link it in this column right here, in this cell right here. So over the course of the semester, we'll be, populating this as we proceed through things. Now is the chance, does anyone have any questions from what we've covered so far? I haven't talked about what the exam like weight or anything like that is. So I'll get to that. I'm about to open the syllabus. Um, awesome. Okay, so here's my syllabus for this class. I'm gonna close, boom, boom, close those two tabs. I'm really good at opening a web browser and then keeping lots of tabs open. I don't know about the rest of you guys, but I can open a web browser and keep tabs open for like 3 months, have 50 tabs open, never go back to any of them. I'm really good at that. Okay, Chemistry 1330, Organic and Biochemistry for Non-Science Majors / Chemistry for Non-Science Majors. This is a 3-hour class. We're teaching it in the spring of 2026. It will meet on Mondays and Wednesdays, 11 till 12:20. Our meeting place is this link. You must join with SSO through your Texas State account. Here is the link for accessing that. Instructor info. I'm Dr. Joel Gray. You can call me Joel. You can call me Dr. Joel. You can call me Dr. Gray. I'm fine with any of those. My email is joelgray@txstate.edu, or my net ID is jg1345@txstate.edu. Office location, Zoom. Office hours. I've got office hours right after this class from 12:30 till 1:30. Here's the Zoom link. So that will be the exact same for the entire semester. So anytime you want to join, and that will not require SSO. So in the event that you have issues doing the SSO login, you can join that and say, hey, I'm having trouble. This is a designated time when I will be available. That is not to say that is the only time that I'm available. If you have class during that time, or you're like, hey, I want to eat lunch, don't worry and think like, oh, I got to email them and tell them, hey, I got to have a good reason. Oh, if you want to eat lunch, I hate to tell you this, but that's a good reason. Not only because lunch is great, but because you need food and fuel. Um, you don't have to email me with why. Just say, hey, can you meet at 2 on Tuesdays? And I'll say, yes, I can, or no, I can't. I can't do Tuesday, but how about Thursday? Um, just email me with a proposed time to meet rather than having to volley questions and answers back and forth. My preferred method of contact is email. Um, Expected response time, I will do my best, and I'm going to aim to do my best to respond within 24 business hour days. What I mean by that is if you email me on Monday, I'll respond on Tuesday or no later than Tuesday. Email me on Friday, well, Friday is a business day. I can get back to you by Monday. That's just so I can try to have some boundaries and that you can have some boundaries as well. Um, if there's something that's very urgent, and I will admit that I do respond to emails on the weekends. I just try not to. Um, you might over the course of the semester, and I hope that you don't, or maybe in my 1310 class, you're like, you don't try to respond to emails on the weekends, but man, you seem to not try to respond to emails on Wednesdays. Um, I'm working on that. I will work to do better about that. But this is my way of saying, like, listen, if you have something that's pressing and I haven't responded to you within 24 hours, don't hesitate to send me another email. I will again do my best to respond as expeditiously, Expedia. Yeah, I'm going to respond with expedia.com. Expeditiously. That sounds like I'm going on an expedition, though. So I will do my best to respond as quickly as possible so that we can address whatever issue it is. Usually, what happens is somebody sends me an email that requires like 2 or 3 actions on my behalf, and I'm like, ooh, oh man, if I email this person, they're going to tell me this, and I don't think that's going to, oh, I should stop doing that because that doesn't help anyone. And that just kicks the can and doesn't resolve the issue. Okay, so course description. This course is the second of 2 lecture courses for non-science majors. Surveys fundamental concepts in organic and biochemistry, um, and we apply them to some contemporary topics. So we'll talk about lots of different components of biological systems as well as chemistry. We're going to use lots of stuff that we talked about last semester. Today is going to be a review, and whenever we encounter things, we'll review them again as well. Um, this is a core curriculum course. That's not right. What I think most people are most interested in and want to know about is what's the breakdown of the class. You have quizzes. There will be approximately 13 quizzes administered over the course of the semester. 3 of those quiz grades will be dropped. If that number grows, like if I give an extra quiz or something like that, I will of course notify you guys, but also that will mean 4 quiz grades will be dropped. I would think about it as the top 10 quiz grades are the ones that go into the grade book. What I have right now on your calendar on Canvas is I've got 13 scheduled. If I give you another one, I will notify you and say, hey, here's an extra quiz. But keep in mind the top 10 quiz grades are going to be dropped. Now they will be posted on Mondays. We have not had one posted. Your first one will be posted this upcoming Monday. It will cover the material that we're going to go over. This quiz will be due on Wednesdays by 11:59 p.m. You can take it at any point. It will be administered using Proctorio. You will have 2 attempts, and your highest score will be the one that is recorded. It will be a closed note quiz. Think about this as I'm just trying to answer these questions as quickly as possible. I want to recall this information. So think about them more as like conceptual and logic based. You will have homework assignments. There will be a total of 14. Your 2 lowest will be dropped. They will be posted on Mondays. And what that means is that your first one will be posted on Monday and it will be due the next following Monday at 11:59 p.m. So you're going to have roughly 7 full days to complete your homework assignment. The homework assignment might be an H5P or an HTML5 thing. They're going to be based in Canvas, so it's going to give you like grade feedback. And they're going to ideally be things that are a little bit enjoyable as opposed to kind of onerous. I like that word onerous. It's going to be like there's an H5P that can do a crossword puzzle. So I'll put the prompts in and then it will scatter it up. And I mean, that's just another way of looking at like, hey, what's the definition for this? Midterm exams, there will be 3 of them, and they are worth 15% each. They are going to be administered on the 18th of February, the 1st of April, the 29th of April. Your final exam replaces if higher. Does that say the final exam replaces 1 if higher? No. Does it say it replaces your 2 lowest? Nope. What that means is that your final exam score will replace the score that you get if your final exam is higher, it will replace the score for the exam on February 18th or April 1st or April 29th. If your final exam score is higher than all of these, what does that mean? Well, that means your final exam score replaces all of those. If your final exam score is lower than all of these, it will not replace any of them. Okay. Does anyone have any questions about that? Okay, one of your classmates is laughing kind of hysterically, and I'm not sure if that's like I'm watching a YouTube video of a donkey kicking someone or what, or I don't know. That would be funny. My kids watch YouTube videos of people getting hit with stuff. So, okay, you got a laughing emoji floating from the top of the bottom of the screen. Okay, so I'm just going to go ahead and. Okay, so your final exam is worth 15% of your grade. I don't know what to say beyond that. It's Monday, May 11th at 8 a.m. It is comprehensive and it is required. Another way of saying comprehensive is cumulative. So all of the information that you're going to be tested over the course of the semester, you'll be tested over on the final exam. I thought about making the final exam worth 95%, but changed my mind. Not really. I didn't really consider that, but I just wanted to throw that out there, see if anyone was like, whoa, man, he's so nice. He was going to make it worth 95%, but he didn't. That's so cool. Are we still allowed note cards? Yes, you are allowed 1 3x5 note card on each of your exams, front and back, right? Whatever you want on there, handwritten, printed, whatever. The biggest difference if you took my 1310 class is that our exams are going to be administered during our class periods. There's very little to no wiggle room on that. Um, so if you are someone who's like, oh, I'm working full time and I can't make it to any of the exams, I would recommend talking to an academic advisor, or talk to me and an academic advisor and we can see what we can do. um, but that's kind of a problem. Then participation participation is 5% of your grade. 20 plus 15 is 35 plus 45 is 80, right? Yeah, 35, 80. 80 plus 15 is 95, plus 5 is 100%. Perfect. I added that all up correctly. Your participation is worth 5% of your grade. How are you evaluated for your participation? It's determined based on Zoom participation. There are going to be a couple of days where everyone's going to automatically get Zoom participation, but also with Canvas discussions. So we'll use the discussion boards on Canvas, and I'm going to share my screen on that in just a moment. There will be approximately 24 Zoom participation opportunities and 24 discussions. Good news, everybody. My best friend, potential spam, is calling me. I don't know if anyone else knows potential spam. I kind of want to answer it and just talk because that's what I like to do, but my wife always encourages me to not do that, so I'm not going to. And it's somebody, oh, we're coming through the neighborhood, we're checking to see if you need a new roof, we'd like to do free roof inspection. Um, and I always just say no. But sometimes I'll say, oh, wait, whoa, huh? And then they hang up after like 20 seconds of me doing a bad job of trolling them. Okay, so Zoom participation. There's typically going to be questions at the beginning of class, a couple of questions peppered throughout the class, and then a couple of questions at the end. The way that I'm trying to do it this semester is I've got starter questions, during class questions, and then closer questions. The starter questions are going to be relying on like recall, or do you have any background information on this topic? Like, where are you? For instance, when we talk about amino acids, I might ask the question, have you ever heard of an amino acid? Have you ever heard the phrase amino acids outside of this class? And if the answer is yes, okay, cool. Then at the end of class, I'll ask, select a definition of amino acids. Because what I'm doing there is I'm trying to assess who came in with no knowledge of an amino acid. And now at the end of the class period, to kind of evaluate how effective the instruction was, who knows the definition of an amino acid? If we started the class with two people answering that they've heard of an amino acid, and then by the end of class, 95% of the class knows the definition of amino acids, that to me is like, okay, good, you have this information. Then, whenever it comes to the actual exam, you'll have a question that asks you about amino acids and the definition. What is a good definition of an amino acid? And so that would be kind of validation, like, hey, I started with nobody knowing what that was. And then initially they got it. And then after, or whenever they were tested on it, they understood it as well. So spot on. This is great. Okay. So there will be Zoom participation opportunities. I am not going to say, oh, well, you had to answer this question to get credit. When it comes to Zoom participation and polls and responding to the polls, I'm looking for participation. I'm looking for you to answer the questions. I'm looking for you to think about it and answer it as best you can. I'm not looking for, oh, well, you didn't get it right, so minus 1,000. That's punitive. I want you to take a chance, because my understanding is that education in school is for learning. So there will be those discussions, 24 discussions. Will we still get poll questions? Yes, we will still get poll questions. That is exactly what I'm talking about. Zoom participation or poll questions. Before I get to discussions, there will be 48 graded items worth 5%. A total of 4 of those will be dropped from this category. Now, what that means is if you never come to class, you will miss out on those Zoom participation opportunities. There will be some where everyone gets credit. For example, today, everyone will get credit. Um, but if you never come to class and never answer a poll question, you're not going to get credit for answering a poll question. Now, in the event that you work and you can never participate in the Zoom questions, well, we're going to have discussions. And these discussions are going to be administered on Canvas. Now, this is a class of, I think, 35 people or so. And what I've done for the discussions is I've broken everyone into groups of, I think it's like 7 or 8 people. You will be with those 7 or 8 people for the entirety of the semester. And so your discussions, when you answer those questions, will be going to only those people. Discussions are going to be posted on class days, and you'll have 48 hours to answer them. Each discussion will basically be worth 2 points. For 1 point, post your first discussion. Please post the following things as a list or complete sentences. This is just low-hanging fruit, get to know you. And just demonstrate that you know how to do it. And I want to see some engagement. So what's your major? Your favorite thing about Texas State or San Marcos? And your favorite outdoor activity? You'll get 1 point for answering that, and then you'll get 1 more point for responding to a classmate. Now, with 3 pieces of what you think will be good advice for someone taking this class, think about the fact that this class is online instead of in person. Consider the regularity of quizzes and assignments. If you have something where it's like, oh, I set alarms for myself on my phone so that I don't forget quizzes, that would be something good. And I got to tell you, if I see 30 some odd people respond with attend class and or go to Zooms and or watch Zooms, I'm gonna be disappointed. I mean, you could have said like crush a Red Bull 5 minutes before class, but you said go to class. Um, I know that's kind of mean of me to say that. But here we are. So think about it as you're going to get 2 points for Zoom participation, 2 points for discussion participation. Kind of, yeah, no boring answers. Yeah, I like that. So each class period is basically going to be worth 4 points. If you never attend or never participate in either of them, the highest you're going to get in this class is a 95%. There will be some extra credit opportunities, but you're going to be starting out with 95 as your highest. And these are most of the time, the discussion is going to be something like write an answer or write a multiple choice question on this particular topic. So it's what I want the discussion to be is something that, people can look at and they can, it can help them by looking at what their peers are thinking. Alternatively, it can help you maybe by getting your own thoughts down on paper. Not paper, though, internet paper. Okay. Does anyone have any questions about policies related to this class, like attendance or work or anything like that? Well, then, what I'm going to do, class started at 11, so we have until 12:20. Great. Well, what I'm going to do is I'm going to go to my slide deck, and I'm going to switch my screen share, stop the share, start the share right here. If you've not taken a class from me, what I like to do, or what I tend to do, is I have a stylus, not a stylist, a stylus. So I'll write on the screen. So we've got a review of general chemistry, and these are some of the bigger points from your 1310 class. If these are things that you maybe struggled with or needed a little bit more clarity on, and I don't answer it in this, then please don't hesitate to contact me, and I'm glad to either give you some example sorts of problems or other resources. But the first thing that I want to get after is atomic structure. And every time I see the word atomic, I always think of atom just because that's the root word. So, what is the structure of an atom? Well, there are a couple of different models of the structure of an atom. At first it was like, hey, an atom must be like this blue sphere. Awesome. And then as time went on, people were like, we can do better than that. And it was, oh, well, you know what? I think if you remember, this is the plum pudding model. Um, and the idea was, well, an atom is like this, it's like this charged ball. It's like positive, but then we've got all these negatively charged things randomly peppered throughout. But it's like a positive cloud with a bunch of negatives floating around it. There's a plum pudding model is what that's called. And then a guy named Ernest Rutherford was like, as cute as the name plum pudding sounds, I think we can do better than that. And he ultimately deciphered that, well, there's a nucleus within an atom. Just like in any living cell, there's a nucleus. An atom has a nucleus. And that's where the heart of it all is. The nucleus consists of two different subatomic particles, neutrons and protons. Neutrons have no charge, protons have a positive charge. And then he said, you know what? Actually, there is like a cloud or a space outside of that, and it is charged, and it's made up of your electrons, negatively charged. So your negatively charged electrons are kind of in this amorphous or this like undefined shape around the nucleus. And everyone was like, wow, we really liked the plum pudding model because it made us think of plum pudding, but this kind of does make more sense. And Ernest Rutherford was like, it does. In part because I did a fantastic experiment on it. And what he did was he used gold foil and he sent charged particles at that gold foil. And then he detected how these charged particles reacted to this gold foil. And he said, you know what? If we've got um, random charges in this organization, well, then we're going to get this result. And he did this experiment where it was like, we've got two possible results. If it's this result, then the plum pudding model is valid. If it's this result, the plum pudding model is not good. And instead, we've got this nuclear or nucleus model for an atom. And sure enough, his experiment revealed that the plum pudding model was not true. And maybe not true, but the theory of the plum pudding model had some deficiencies to it. Now, at the heart of it all was your subatomic particles. And I apologize, the formatting got mixed up here. I'm going to scribble these out just so I can rewrite them. We've got our protons, our neutrons. Those are found within the nucleus. The mass of a proton is approximately 1 AMU, also known as an atomic mass unit. The mass of a neutron is approximately 1 AMU as well. So the mass of an atom is all found in the nucleus and is composed of your protons and neutrons. Electrons, by comparison, they have a mass of approximately 0 AMU. So no apparent mass. And they are found outside of the nucleus. Okay, so important things are nucleus has mass. Well, your nucleus also has protons and neutrons. And your protons and neutrons, which have mass, make up the mass of an atom. Now, the charges. Your protons are positively charged. Your neutrons are neutral and they have 0 charge whatsoever. And your electrons are negatively charged. So it's important to know the identity of your subatomic particles. It's also important to know where they are. And so what are they? What is their mass? Where are they found? And what is their charge? Now, with respect to these different things, your protons are going to be equal to, or the number of protons that an atom has is equal to the atomic number. The atomic number helps you identify an atom. You might be looking at this and saying, oh, I remember that, but how? Well, the answer is your periodic table. And we're going to come back to the periodic table in just a moment. But protons are kind of your guiding idea of what atom or what an atom is based on its number of protons. And what does that mean for the identity of an atom? Neutrons are your mass number minus your protons. So if I told you that an atom had a mass number of 72, you'd be like, oh, okay, so the mass number is 72. That means it has, well, a number of protons and neutrons that equals 72 total. So if I said, oh, well, the mass number is 72 and the number of protons is 38. Does this tell you anything about the number of electrons? Does it explicitly tell you about the number of electrons? Oh, no, it doesn't. Does it tell you anything about the number of neutrons? It does. Somebody sent me a private message. I was in your 1310 class exactly a year ago. How is the newborn? Thank you for asking. He's doing well. I have let's see, it's the 21st. So in 7 days, my youngest son will be uh, 11 months. So, okay. Sorry, I get distracted. Um, so 72 is your mass number, 38 is your number of protons, and from that we can decipher that 34 is our number of neutrons. Now, from this information right here, we don't have a precise number of electrons. You can deduce it and you can maybe make some good guesses. But from this alone, I can't say, oh, well, I know that there are exactly 34 electrons or 38 electrons. Now, if I said this is an atom with a 0 charge, yes, I got a private message that says neutral charge would tell us though, right? Yes, it would. If I said this is an atom with a neutral charge, then you could say, oh, well, based on it having 38 positively charged protons and then having a 0 overall charge, I know that it has to have 38 negatively charged electrons. And we're going to come back to that. That's called an ion. We'll come back to that though. So I hope that some of this stuff is kind of coming back and you're like, ah, oh, yeah. Okay, it's there. I gotcha. Um, Now, some of these things I'm showing to like jog your memory. You're not going to be asked explicit questions over this, but you might be asked questions about, hey, this thing is an ion. I then want you to say, okay, that means it's positively charged, or positively or negatively charged. If something is identified as an ion, it doesn't necessarily have a positive charge. It doesn't necessarily have a negative charge. If I say something is an ion, I want you to think it is charged. It has either a positive or a negative charge. Now, there are some unique terms. A cation is positively charged, an anion is negatively charged. But I want you to remember ion means charged. Okay. Now, before we get into that, though, I want to remind you of and just kind of bring back the term of an isotope. Isotopes are atoms with the same number of protons but different number of neutrons. What's important here, or maybe what's most important, is the number of protons. That's basically never going to change, because if you change the number of protons, you're changing the identity of the element. So if I said I had an atom, like hydrogen, for instance, has an atomic number of 1, and I said I have an atom with 1 proton, I would want you to say, okay, well, if you have an atom with exactly 1 proton, you have an atom of hydrogen. If I said, oh, well, I have a hydrogen with 2 protons, it's cool. It's the newest hydrogen. You've never even heard of it. It's so cool and new. You would safely be able to say, no, you don't. And then I'd be like, oh, but I do. It's so cool. Like you maybe haven't heard about it yet, but it's so cool. You are gonna want this. And then you're gonna say, that can't exist. And I'd be like, you're just jealous. Jealous. This is what you are. You know I'm cool. Um, because if you change the number of protons, you change the identity. Neutrons, however, if you change the number of neutrons, for instance, here we have hydrogen or one hydrogen. Here is two hydrogen. Here is three hydrogen. The mass is changing. Why is the mass changing? Because the number of neutrons is changing. Hydrogen with four neutrons has a mass of five. So isotopes are where you change the number of neutrons. You don't touch the number of electrons. Can you have an isotope that is charged? Yeah, you can. Because the number of neutrons is different and the number of electrons is different. Isn't technically three unstable? Yes. Three hydrogen is also known as tritium, and it is a little bit. I'm not a nuclear chemist, so I don't know about how what its what is it, half-life or its lifespan is, but um two hydrogen and three hydrogen are both less common and a little bit more unstable, but I don't know what the conditions are exactly. I know that three is tritium and two is deuterium. And I know that whenever people use two hydrogen, which I heard about somebody making water out of deuterium or with deuterium, and they said that it had a sweet taste, which I was like, oh, that's interesting. Um, Whenever you use this, this is like my juvenile self laughs at this. When you use two hydrogen, you uh, deuterate the substance. So if you had water with nothing but two H or this specific isotope of hydrogen, it's referred to as deuterated water. And that just makes me think of like, you mean dude? Dude? Or it sounds like something one of my kids would say regarding farts. Sorry. Okay. Another thing that we talked about, and we will talk about this a little bit when it comes to organic chemistry. Um, I just want to bring this back up in terms of like this series of pictures illustrates where electrons can be found. These subshells, these what are known as atomic orbitals, show where electrons can be found. And each one of these holds two electrons. So the p subshell holds a total of two, two, two. A p subshell holds a grand total of six electrons. And I'm sharing this with you just to kind of give you a memory of like, okay, well, protons and neutrons are in the nucleus. Electrons, where are they? Oh yeah, they're kind of in random places, but it's not so random that it's like, I don't know, one could be way over there in Egypt, and one could be right over there in Antarctica. There is a little bit of order and organization to them. Okay, now onto the periodic table. Which one of these represents an element? Oh, that's a little bit tough. Right here, we've got water. That's a compound. So that's a oxygen atom and two hydrogen atoms. Right here in cell C, we've got this that's a compound, and then this that's an independent element. But this right here, this would be something like O2. That's two oxygen atoms. Now, when we look at an elemental symbol, here we've got the elemental symbol for iron. You've got 26 as the atomic number, the symbol is Fe, and the atomic mass is 55.8. When you look at the periodic table, usually what you're going to see is a whole number. That is the number of protons that an atom of this has. So if we looked at polonium right here, this particular illustration of the periodic table doesn't have the atomic mass or the mass average on there, but it does say PO 84. 84 is the number of protons that this has. How from this particular periodic table, because it doesn't have the atomic number or the atomic mass, we could not deduce how many neutrons it has. So we'd only be able to say, oh, okay, polonium has 84 protons. If I said, oh, you've got neutral polonium, you'd be able to say, oh, okay, well, it's got 84 protons, therefore it must have 84 electrons in order for it to be neutral. That's the sort of information you could extract from this periodic table. The periodic table that I'm going to share with you guys for exams and stuff will have your atomic number and your mass average. So I'd be able to say, okay, we'll deduce how many neutrons this has. Now, on a scale of 1 to 5, 1 being, yeah, this is pretty familiar, or 1 being, yes, I have this memorized, and 5 being, when do we get to talk about William Shakespeare? How would you rate yourself? And you can send it as a private message to me. I mean, I'm getting lots of questions that seem to be like, yeah, I'm kind of there. I'm pretty close. That's what I'm liking to see. That's what I'm wanting to see. I don't think anyone's going to be like, when's the, when are we going to talk about the Great Depression? I thought that's what it was. Okay. Atomic orbitals. Yeah, that's not going to be a huge part of this class. Lots of this class, because we're talking about biochemistry, we are going to be, you know, this is one of the things that I like about chemistry is that you start out with, oh, cool, 118 elements on the periodic table. Certainly every chemist is going to know everything about all of these. No. My background is as a biochemist, and actually, I'm going to go back. When it comes to biochemistry, you're really most interested, or actually more advanced chemistries, you're most interested in these main group elements, the ones that I circled here. These guys right here, your transition metals, you use them from time to time, but only like nuclear chemists are going to use things way down here or way down here. As a biochemist, carbon, nitrogen, oxygen, hydrogen, selenium, sulfur, that's going to account for most of the elements that I deal with or that I'm concerned with. So that is just kind of like not a warning, but just give yourself some awareness on that. So a molecule is a group of atoms chemically bonded together. Here's a water molecule, and here's a carbon dioxide molecule, H2O, CO2. Now, we will talk about things that are a little bit more complicated and involved. So here what we have is a molecule of caffeine. 1, 2, 3, 4, 5, 6, 7, 8. So C8 is our formula for the number of carbons. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. 10. And then red is oxygen, 1, 2. Nitrogen is 1, 2, 3, 4. So that would be an example of the formula for this molecule. I accounted for all of the different atoms. And these are all atoms that are bound together. Now, one of the important parts about this is that these all have subscripts. So if I were to change this from C8 to C9, I have changed the molecule. It's no longer caffeine. How do we know which element to write down first? That's a great question. The answer to that is you are going to look at the one that is typically farthest to the left that is not a hydrogen. So carbon, for what we're going to do in this class, I would default to carbon's the first one that you're going to write. And generally what I do is CHNO, because if you look at the periodic table, C and then hydrogen is typically bound to those carbons. That's why I would write hydrogen next, and then NO, we're moving from left to right on the periodic table. So if you start out with, okay, I'm going to write carbon first and then hydrogen after that, if I have any, and then I'm going to go left to right on the periodic table. That's a good place to go with. Now, if we see something like this, well, these are not bound to one another. So this is H2O. It's not H6O3. It's H2O, but we use a coefficient, a 3 in front of them to illustrate that. Now, what is very important in this class is being able to draw Lewis structures. A Lewis structure, or maybe not draw, but at least identify a Lewis structure and a correct Lewis structure. Now, in order to do this, you have to have some familiarity with the periodic table or with this chart right here. This shows the number of valence electrons. And this is, I would imagine that lots of you guys are probably like, valence, that's the word. I knew it. I knew it. I knew it. Because that's a word that people have a tendency to get hung up on. They're like, I know it's important, but I can't remember exactly what it means. A valence electron, or your valence electrons, are your outermost electrons. Valence electrons are your outermost electrons. Will we get this sheet on exams, or will we only be provided what we write on our note card? You're only provided what you write on your note card. I'll give you a periodic table. So if you take this and look at the periodic table, I want you to kind of overlay these things. And actually, now that I look ahead on my slides, so if you look at this, your noble gases, they're the farthest to the right on this chart. And what I want you to recognize about this is that they have 8 dots, 2, 4, 6, 8 dots surrounding that symbol. Well, your noble gases are right here. That's farthest to the right. So I always try to keep this as, well, 8. Then the next column, group 7A, fluorine is in there. Fluorine has 7 valence electrons around it. Oh, lo and behold, fluorine is 7. Oxygen has 6 valence electrons. Nitrogen has 5 valence electrons. If you do that, that's going to help out quite a bit. And then you don't have to use, you don't have to put this on your note card and use up that valuable real estate. But one thing that is shown here is that group 17 or group 7A might be shown on a periodic table as group 17. So you need to be able to kind of translate those things to one another. Your valence electrons are your outermost electrons, and those are unique because those are the ones that are involved in bonding. Involved in bonding. They're also going to be lost or gained in order to form a particular ion. So if we look at Na versus Na plus, I want you to respond with A or B. Which one of these, Na or Na plus, which one of those has more total electrons? A or B? I got one response as a direct message. A is absolutely correct. Because when something loses an electron, it's losing a negatively charged thing. So that means it becomes positive. Okay? Now, F versus F minus. A versus B. Which one of these has more electrons? You're absolutely right. B, because it gained an electron, it gained a negatively charged thing. Okay, so when you think about ions and you think about valence electrons, I want you to try to think about those two things going hand in hand with one another. In order to become an ion, is it going to lose an outer electron or what's known as an inner electron? And quick question I struggle sorry. I sometimes struggle with placing the dots in the right places, but I usually get the correct amount. Would that affect me? It's not going to affect you. So I think that the heart of that question is, or maybe not the heart of that question, but what's what I don't really address, and I need to, or sorry, what I didn't really address is, what does a question look like with respect to Lewis structures? Um, you'll see a multiple choice question, whichy is correct. I'm going to go with answer A, B, C, and D. Okay, so answer A. Which of these is the correct Lewis structure for fluorine? Or, okay. And I'm sorry for my drawing there. The drawings on the exam will be more clear. Which one of these is the correct Lewis structure? So that means it shows the correct number of valence electrons. Um, all what I want you to recognize is that, well, only one of them has 7 valence electrons, and that's answer option B. So I don't want you to think, oh, I'm going to get to the exam and answer B is going to be this and answer C is going to be this. I'm not going to do that. You're going to have like, okay, yeah, only one of these is right based on the total number of valence electrons that's drawn. Um, does that help for the person who asked that question privately? Great. I'm happy to hear that. Okay. So I want you to try to think about common ions, valence electrons, and this is a little bit of a stretch, but atomic orbitals kind of in the same way, or kind of throw those things all together and try to think about them as like an illustration of an atom. And so one of the ways that you could think about that is if we have fluorine, okay, so we've got fluorine with a total of 7 valence electrons. If it gets this 8th valence electron, where do you think that 8th valence electron is going to go? Do you think that it's going to go to a S subshell or a P subshell? S or P as your answer. And to give you another way of thinking about it, 2 contains, or sorry, the S subshell holds 2 electrons. And if I were to write the electron configuration for this right here, I'd write S2P5. How many total electrons can the P subshell? And I'm kind of belaboring this, but because everyone's selecting the right answer, but how many total electrons can the P subshell hold? 6. So if I look at this, I'm like, oh, where's this extra electron going to go? Well, the P subshell can hold 6. There's 5 in there. So I think it's going to go to the P subshell. Could everyone give me a plus symbol in the chat if they follow that? And anything else if, wait a minute. Still, when are we talking about William Shakespeare? No. Got a private message that said no. Okay. So my point here is what I'm trying to illustrate is this right here is kind of a symbolic way of saying where electrons are. And when we're building an atom, what we first do is we fill these S subshells. Then we go to these P subshells. Well, it's not drawn to scale here, but we can only put 2 electrons in here. Any more electrons have to go into this space. And these, if you were to take this model right here and overlay it over this, it would look like this. If I were to take this right here, this would look like this. If I were to take this right here, it would look like this. Quick question on the electron configs. We are only using the subshells to show the valence electron, not the whole atom's electrons, correct? That's what we're aiming for. So if I were to take an electron from, let's say, fluorine, well, chances are that electron is going to be taken from a p subshell. Now, that's not if that's something that you're having trouble wrapping your mind around, don't stress about it too much. I'd like you to work more on making sure that you understand the Lewis structures and how to draw those and how to interpret those than anything else. Can you show us an atomic orbital for chlorine? So chlorine, yes, I can. Chlorine, I'm going to draw a neutral chlorine. Oh, that's not what I want to do. I'm going to erase. Oh, wait, no, I can clear all this ink on my slide. I'm going to show you chlorine, Cl. I'm going to go back so I can get a neutral chlorine has a total of 17 valence electrons, or 17 total electrons. 7 valence. VE, 17 valence electrons. Now, if I were to write out the what's known as electron configuration for chlorine, it would be 1s2, 2s2, 2p6. How many electrons have I counted for here? Well, I add my exponents. 2 plus 2 is 4, plus 6 gets to 10. And then I've got 3s2, 3p. What number should I put there? Think about adding your exponents to get to 5 is absolutely correct. 3p5. So if I asked you about the valence electron configuration or the valence, where are the electrons for the valence electrons for chlorine? That would be 3s2, 3p5. So if I were to add an electron to this or to chlorine to make Cl minus, that would go into this subshell right here. It would be going into that P subshell. Okay. Now, again, this isn't something that I want you to be like wringing your hands and stressed about so much. I'm trying to like bring these things back. If you feel better about electron configuration, or if you feel best about the Lewis structures and a figure like this and saying, I know exactly how to draw a Lewis structure given this table right here, awesome. If I asked you for the Lewis structure of this ion right here, it would look like this. I'm going to draw a total of 8 valence electrons. I'm also going to include that negative symbol because this is an ion. Cl, by comparison, looks like this. It has 7 valence electrons. This is neutral. This is a negatively charged ion. Now, when it comes to ions, we also have different names. We have a cation, which is a positively charged ion. Anions are negatively charged ions. Now, the biggest difference between them is this shows us groups. This shows us where these are on the periodic table. So groups 1 through 3, those are going to make cations. These are also metals. Lithium, for example, Li. It's a group 1 metal. It's going to form a +1 cation. Magnesium is a +2 cation or a 2 cation. It is a group 2 metal. Aluminum is a 3+ cation or a 3 cation. It's a 3+ ion. Naming your cations is super easy. The lithium ion is known as lithium ion. The sodium ion is the sodium ion. The magnesium ion is the magnesium ion. You don't change anything about the name of the element to make the resulting ion. Anions, on the other hand, there's a little bit more to it. Nitrogen. Okay. Nitrogen will accept 3 electrons, making it a negatively charged ion, N3 minus. To give that the correct name, you call it the nitride ion. So you use the suffix IDE and you throw the word ion on after it. Now, these other ones down at the very bottom here, we've got copper, silver, zinc, iron. These are all transition metals, and they're a little bit hairy. I'm not going to ask you to know rules about transition metals. But for fluorine, for example, that's the fluoride ion. Okay. There are also things known as polyatomic ions. Poly meaning multiple, atom meaning atom, or polyatomic meaning multiple atoms. Multiple atoms come together to have something that is charged. This is a table that I would provide you with for familiarity. I don't know how much I would ask. I don't know how much is going to surface on this and how much we'll see it other than like this ion is added. So there you go. Okay. Now, one of the really important things in this class, and I know that you might be like, oh my gosh, this is day one, man. I thought we were just supposed to talk about the syllabus, take a nap, and leave. Um, I'm not going to like burn through everything so that I can be like, haha, I got through everything. Um, some of these things we're going to revisit. Many of these things we're going to revisit when they're particularly relevant. Um, Covalent bonding. This is where electrons are shared. So sharing is caring, but sharing is also a hallmark of covalent bonding. Okay. Now, there are degrees of sharing. And whenever I teach 1310 and teach about covalent bonding, it comes up that I'll talk about my kids when they share things. Sometimes they're like, "Oh yeah, I share this, and I will gladly share this." Other things are not quite so much. So it's like one of them has I can't think of things they share. Oh boy. But just imagine that it's like they both really love PlayStation. Are they going to share it where one can take the PlayStation to their friend's house or something like that? You get it right now. You can hold on to it. In order for that to happen, one of my kids would be like, I don't really care about the PlayStation. And that would be, well, yeah, they're sharing, but really only one of them has it. Now, we do that same sort of thing when it comes to sharing of electrons between different atoms. And we have this phenomenon known as electronegativity. Electronegativity is the ability of an atom to attract shared electrons. So, what trends do you notice in the periodic table? Well, one of the things that I want you to notice, there's two things that I really want you to notice. One of them is that fluorine is your most electronegative element, has an electronegativity of approximately 4. Francium is basically your least electronegative element. This has an electronegativity of 0.7. Now, the species that is more electronegative wants electrons more than the other. So if you had francium and fluorine and they were sharing electrons, tell me which of them would want the electrons more, fluorine or francium, F or FR? You're absolutely right. Okay, what about F sharing electrons with C? F or C? Which one wants the electrons more? Perfect. Um, F and F. Well, they're identical, so it's the same. So they both want the electrons desperately, but they're not fighting about it. So what this means is that if you had this electron, I'm going to draw it straight in the middle between F and C. That model right there, where I drew that, isn't really accurate. It'd be more accurate, I'm going to change the colors here, to draw it like here, to draw it closer to the fluorine than it is to the carbon. Give me a 5 in the chat if that makes sense. Okay. Um, that's where we're going to stop today because it is 12:10. It's a little bit early. But we're doing a review, so that's always like a ton of information, and I don't want to overwhelm everyone on day one. We're gonna pick this stuff back up again on Monday, and we'll go back over this, and I'll do my best to clear up some confusion, and then we're gonna jump into organic chemistry. Um, and if anyone here has any friends who have taken organic chemistry, they might be like, "Oh my gosh, organic's the hardest class ever." Um, it is a tough class. What we're going to talk about is that we're going to talk about aspects of organic chemistry, but I don't want you to think like, "Oh my gosh, no one's ever passed this." Yeah, everyone's passed this who's passed the class. Yeah, it's a completely self-fulfilling sentence. Um, if it was F star FR would lose their electron and it would make. I got a private message question that was asking about the fluorine francium um, shared electron. You're absolutely right. Francium would not keep that electron. It would basically say, I don't need it, and fluorine would take it on. I forgot for the exams, are they all online as well, or do we go somewhere to be proctored? They are. All of our exams are online, and they're going to be proctored during our class period. Your quizzes are going to be administered using Proctorio, and your first quiz isn't posted until Monday. You've got a discussion, though, that is going up. Oh, it should be up now. Contribute to that. The final is online also. Everything for this class is online. Contribute to the discussion, 2 points to earn, and remember the people in your discussion group are going to be the people who are in it for the remainder of the semester. How exactly would the exams be done? Like through a breakout room or dot dot dot? They're going to be administered by or on Canvas. That's where the exam itself is going to be. You're going to join through Zoom using like a device like your phone or something like that. And you're going to have the phone positioned like this. And you can see that's one of my kids on my phone. And I have lots of notifications I'm ignoring. Your phone is going to be positioned to capture your workspace as well as your screen. So I'll be able to look at your cell in Zoom and see that you are working on the exam. And so that's how we're going to do it. We'll get more into that a little bit later on. I'll give you some suggestions for how to do that and everything as we get closer to our first exam, which is February 11th. In the meantime, though, I think it's the 11th. In the meantime, I hope you have a great Wednesday. I hope you have a great weekend. Make sure that you do the discussion so that you can start out on the right foot. Everyone's getting credit for today's Zoom, and I will see you guys on Monday. Email me if you have any questions. I will post our recording a little bit later today. It's got to convert and then it's going to be ready. All right. Thank y'all.